Alright guys, welcome to RC Mojo. This week we're back for some more quadcopter tinkering. We're going to swap the receiver out, add an altitude sensor, and check out some budget goggles. Currently the quad has a nice little FlySky receiver with a ppm output. It outputs 8 channels in a series of pulses where the length of the pulse represents the stick position. It's essentially the same way that it's been done for decades. Just unlike a receiver with separate servo connections, it doesn't separate out the pulses. As far as I've tested, it seems to work perfectly fine. The only thing that's really missing is telemetry, a way to send information from the quad back to my handset. To replace it, we have a FreeSky RXSR. It has a couple of features that we can make use of that the FlySky really can't do. First, rather than ppm, we can use an S-bus connection. Now S-bus works a lot like the transmit side of an old PC serial port, sending raw data rather than pulses. That means it can send all the stick positions far quicker, lowering the lag or latency and increasing the frame rate. Plus, it's not doing 8 channels, it's doing 16, at least when it's bound to a suitable handset. Next we have the FPort, which is more like the receive side of an old serial port. It's where sensors would plug in so their data can be sent back to the handset via the radio. There's a little more to it, of course. There's a protocol that sits over the hardware, and rather than the plus and minus 12 volts of the old PC RS232 port, it's 5 volts. So we might want to call the S-bus S-port combo a full duplex serial port with a separate transmit and receive. But there's another type which is a half duplex serial port, where instead of 2 connections, the transmit and receive share a single connection which they take turns in using. And it just so happens the FreeSky can do that with FPort. It'll allow the stick positions as well as telemetry to run down the single wire. Very convenient. All we need to do is connect a ground, a power, 5 volts, and the FPort to one of the serial pins on the flight controller. It does require the receiver to be reflashed with different firmware. Now, I'm not going to cover that here as I was learning myself, but it's widely covered on other channels on YouTube and it's really quite easy to do. The plan is, depending on how the rules and regulations go here in the UK, to put together a quad that's a bit bigger so it can carry an HD or 4K camera and show that build in nice lots of detail. Anyway, next we have a BMP280 barometer. Actually, the BMP280 is just a little silver chip in the corner. This is a BMP280 breakout board with its own 3.3 volt power supply. Usually flight controllers seem to only have a 5 volt supply, which the little BMP will tolerate for a while, but it is out of spec. The board takes the 5 volts and makes 3.3 volts to keep everyone happy. Now it's an I2C device, so as well as ground and power, we also need SDA and SCL. Usefully, the KingKong flight controller already has a connector just for I2C devices, so it should be as simple as plug and play. From eBay, I got some pigtails to make it really easy. All being well, it's just going to be a simple point-to-point wiring job. All simple stuff. Sometime later then, we have all the connections lashed up for testing. We've got the receiver connected up with its 3 wires to the flight controller. Now it didn't quite go to plan. The flight controller's receiver connector only supports receive in serial mode, so it worked just fine with S-bus, but not FPort. Instead, I wired it up to the side plug that also has a suitable ground and power, but it also has another serial connection that we can use with FPort. There was a quick change to do in the Betaflight software to tell it where the receiver was, and then it burst into life working perfectly. The barometer was easier still. It's just a straight up pin to pin job, ground to ground, power to power, etc. In Betaflight I enabled the barometer, and after a reset it was up and running. Absolutely no bother. If we turn on the handset and the quad, we now have working telemetry. I've added the altitude, RSSI and TRSS to the top bar on the screen. And I've also added a voice alert, so if we go over 350 feet, it'll tell us. Also, if the signal strength, RSSI, gets a bit low, it'll let us know. If I take the quad for a little walk along the corridor, you can see the signal strength go down a bit. And as I come back, it goes back up. It all seems to be working perfectly. Now I'm not expecting the altitude to be all that accurate, but it should be good enough to give us a feel for what it looks like near 400 feet, and how high I typically fly. The plan is, assuming a typical flight is well under 400 feet, remove the barometer to save a little weight. And of course, if we arm the quad, all the controls are working just as they should. To be honest, the lower latency and higher frame rate probably won't be noticeable unless you were racing, but I'm sure it's not going to hurt. Right, having those great big long wires isn't going to be any good. Not just the weight of them, but there's not enough space to fold them up either. Off camera, I'm going to work out how to fit all the bits on the chassis, then come back and give you a bit of a tour. Here we go then, sometime later, and everything is tucked away nicely. The barometer is attached to one of the ESC mounting screws. It just about fits between the ESC and the flight controller. I've put some heat shrink around it too, just in case vibration causes contact. The wires are just long enough to reach. The receiver is behind the camera now, rather than hanging onto the bottom of the frame. The coax for the two antennas runs out under the ESC and into the antenna tube that's glued in just behind the rear screws. It's not ideal as both the antennas are in the same plane. They should really be at 90 degrees to each other, but I'm sure it's going to be good enough. Its power and FPort wires are just long enough to reach the connector, just like the barometer. The whole lot still fits nicely under the shell, so other than the antennas, there's nothing on the outside to show all of our hard work. Next then, we need to go back out to the field and try a flight with the barometer and see how it goes. Here we are at roughly 120 feet, climbing slowly. I'm using a laptop for the FPV, so I can see the view from the quad and the telemetry at the same time. The signal is a bit weak because I didn't angle the receiver up to aim at the higher altitude. Already by 240 feet, we're higher than I'd usually ever go. Pushing up to the edge of 400 feet, and you can see the whole wide-angle lens thing, everything does look a bit funky. On a quad like this, there's really not much fun to be had flying towards the maximum legal height. Remember, 400 feet from ground level is the highest we're really allowed to go. If I remember correctly, full-size aircraft shouldn't be below 500 feet, giving a nice little buffer. Anyway, test concluded. I know my usual flight heights are well under 250 feet, let alone 400, so there's nothing to worry about there. Next, because I'm tired of trying to see what's going on the laptop screen on a sunny day, we have some budget box goggles. So here we have a set of Eachine EV800DMs. There's really nothing too special about them, but they do have all the basics to get up and running. They have a diversity receiver, a surprisingly good LCD screen, built-in battery, and they have a built-in DVR for recording the flight. In the box we have a directional patch antenna with what I should imagine is a fairly high gain, an omnidirectional low gain antenna for when you're not in line with the patch antenna, a USB charge lead. Now unfortunately it uses a tiny barrel jack which would be all too easy to damage. A nice little micro or USB-C would be nicer, but you can't have everything. A composite video lead, so you can use the goggles as a monitor for an external source. You do get a USB charger, but this one's got an American or some funny Euro plug on the end. No big deal though, most people have USB chargers around that will work just as well. And of course, you do get the goggles themselves. All the good stuff is right at the front around the LCD. The rest is just an empty moulding with some padding to fit round your face. The antennas screw into the two SMA connectors on the corner of the goggles. They don't need to be all that tight, just do them up finger tight and they'll be just fine. There's a degree of adjustment by extending the front of the goggles to move the LCD away from your face. There's an internal lens that does help, but if like me you can't focus on things really close up, you are going to struggle a bit. You can get an extra lens that should help for less than $5, but I've got one on order and it hasn't arrived yet. For the DVR, we need to install a micro SD card. It's only recording SD video, so it doesn't need to be particularly fast. I'm using whatever was cheapest at Argos. I think it's a 32 or 64 gig SanDisk of some sort. It really doesn't matter a whole lot. Just keep in mind you're going to be looking at 300 or 400 megabytes per flight. There's a few buttons around the goggles for power, record, auto scan, mode and playback. They're all covered in the short manual, sort of, but you'll probably want to experiment a little bit before using them in anger, just to get the hang of it. If we turn them on, we get a nice little splash screen, followed by lots of snow because it's not tuned in. We just need to hold the scan button for a couple of seconds and it should find the quad. Now, while playing with it, I did notice it would sometimes lock onto a harmonic rather than the actual frequency. At a very close range, it appears to be okay, but once more than 6 or 7 feet away, you start to lose the picture. Not uncommon on cheap radios, unfortunately, but it's easy to get around. You can scan with the transmitter 15 feet away, or better yet, make a note of the frequency and manually set it. Here we go then. This is from the built-in DVR. Keep in mind we're still using the basic camera in the quad, along with a simple little 25 milliwatt transmitter. That said, I think the quality really isn't bad. It's very usable in flight, and even here, with the picture on the big screen, it's still okay. You wouldn't want to watch a whole video like this, of course, but it's not terrible. With the goggles on, it's so much easier to keep track of the other plane in view. There was no glare on the screen, so it's getting really good contrast. Even against the sky, it was still visible most of the time, where on the laptop it would just vanish. Altogether, a nice little upgrade. It'll make the backpack a bit lighter too, without having to carry around the laptop. Plus, when the indoor truck meetings start up again, I'll be able to look even more of a twit than I usually do. Great stuff. Right, there's one more thing I want to do in this video, and that's change out the battery connectors. Right now it's using the balance connector for the main connection, a little connector that really isn't meant for high power. At the moment, if you really punch it from the hover, the FP video cuts out. That's partly because when all 4 motors are going full whack, they do need quite a bit of power, which causes the volts to drop. I'm guessing the transmitter and the camera are seeing less volts than they need to run, which isn't good. For extra batteries, I've got these 400 mAh 2S35C packs. Roughly the same weight as the included battery, just a slightly different shape. The main problem here though is the huge Dean's connectors. It's quite heavy and not really the right thing for a small quad. To replace them, I'm going to use XT30's, a smaller version of the XT60 I'm already using on larger models as well as trucks. They're essentially very nice bullet connectors in a plastic housing that make sure you get the polarity correct. Now I have been planning to switch my other small LiPos and planes to XT30's at some point anyway. At the moment I've got 3 or 4 different types of connector for different models, which is all a bit of a faff. I think we might as well start standardizing. On the quad, as well as changing the connector, I'm going to swap out the wires for some slightly thicker ones. It's only going to make a small difference, but it won't add much weight, and every little helps. We want the least resistance we can get without making it too heavy. Now in this video I'm not going to show the soldering, I'll save that for a proper quadcopter build in the future. Essentially they're just like soldering up XT60's though, but there's still plenty of guides around on YouTube if you really want the help. Here we have the back end of the quad with the new connector. I had to open up the hole in the cover just a little bit for the bigger wires, but other than that it was just a straight swap. The batteries were just as easy. I've shortened the leads a bit and swapped the connectors. A really quick job. As you can see, we've taken off quite a bit of bulk. If we weigh one of these pigtails, we get 3.3 grams, which may not sound like much, but with a quad this small, that's quite a few % of the total weight. There's more to it than that, of course. We've removed the balance lead and added the XT30's. Now, I really should have done a weigh-in before and after, but I think I was too excited just to get it done. If we add the battery to the quad and power it up to show that it's all there and working, we can weigh it for a final all-out weight. Now keep in mind in the UK, like almost everywhere, the bottom bracket with the least rules is sub 250 grams. So here we go. It's 81.3 grams. That's just a little bit under the limit. It bodes well for building up a fairly agile sub 250 gram quad with HD recording starting from a bare frame. As nice as it will be to have a full HD FPV setup, that's a little bit out of my budget. Now I know this has been done many times before, but I do like working through a build myself rather than just copying somebody else's. Discovery is always part of the fun. So there we go then. As far as this little quad goes, I'm going to call that complete. I'll most likely remove the barometer to save a little bit of weight now we've done the experiments, but other than that it's working a treat. Here in the UK the rules are set to change in a few months, so after that I'll have another look at building a bigger sub 250 quad and making a video series out of it. Should be fun and a good winter project. Now I'm going to add a complete flight on the end of this. Now maybe I'll add some music to it as there's no sound from the flight itself, If you don't like it, you could always mute it, I suppose. So from me, that's it for this week. As always, thanks for watching. Like if you liked, subscribe if you haven't, and leave a comment if there's something on your mind. Bye guys.